Hi, this is Wagner Kamakura. In this tutorial, I'm going to demonstrate a simple but useful tool for text extracting, mining, and coding. And this tool is part of Kate, Kamakura's analytic tools for Excel, which you can download from the web. And you can find details about that in my YouTube channel. Let me briefly describe what ExtractText does. First, as input, you need an Excel sheet where each row contains one document, one text document that you want to text mine. And you can have as many as up to 50,000 rows, 50,000 documents. The first column should contain a document ID, something that identifies each specific document. And the second column should contain the text for each document with up to 5,000 characters. ExtractText works with English, Portuguese, and Spanish, but it works with one language at a time. All documents in a data file should be in one particular language, either English, Spanish, or Portuguese. You cannot mix languages within the same data file. And let me describe now what exactly ExtractText does. It performs three basic functions. The first one is text extracting. Essentially, it extracts every word in each document. Second function is text mining. It goes through the words extracted from each document and filter out words that are typically not very informative. Pronouns, prepositions, one or two or three letter words, symbols, numbers, and words that are very common in the language. They're so common that they do not describe very well the contents of different documents. The other thing that ExtractText does for text mining is to combine words that share the same root. For example, wooden, wood, woody, wooded, woods. They will all be coded as a single item, word wood. The third function that ExtractText does is coding. It dummy codes every document into the words that remained after all the filtering and calculates the frequency of each word across all documents. Then it allows the user to decide how many of those most frequently used words will be kept encoded. It also allows the user to filter out additional words. Some of the remaining words might be too common and might not be very informative, but might not be very discriminating across documents. So it allows the user to filter out whatever words she believes are not useful. And the output produced by ExtractText consists of two files. The first file is an adjacency file that contains a word-by-word similarity table or proximity table or adjacency table that indicates how likely every pair of words is to appear in any document. So it essentially gives you the ranking of one being the least likely to appear in a document and n is the most likely. So the most likely pair of words to appear in a document. And that's the output. It's up to you now to use this adjacency table for additional analysis. For example, you might use this adjacency table as a similarity matrix to do some multidimensional scaling, a unsupervised learning tool available in Kate. MDS allows you to transform that similarity table into a map so that words that appear often in the same document would show close to each other in the map, and words that rarely appear together would show far apart in the map. The other output produced by ExtractText is a frequencies table that lists the number of times each selected word or root is found in each document. It's up to you to then do any subsequent analysis using the frequencies table as your data. For example, you can use frequencies in any unsupervised learning tool available from Kate, such as k-means clustering, correspondence analysis, principal component analysis, latent class analysis, and so on. Or you can use the counts coded in frequencies with additional variables. So you can merge frequencies with some other variables associated with each one of the documents that you can use as a dependent variable in any of the supervised learning tools available from Kate. So you can use, for example, in the example I'm going to show, I have hotel reviews that you're going to use to extract, encode the text. Then you can relate the frequencies obtained from ExtractText with the hotel customer quality ratings for each hotel, and then run either stepwise linear regression, predictive stepwise linear regression, partial least squares, etc. Any of the supervised learning tools available from Kate, which are appropriate for this kind of data. So next, I'm going to show you one example of what you can do with ExtractText. In this example, we have 1,000 guest reviews of hotels in Manhattan, New York. So each row is one guest review. And instead of having document IDs, on the first column, I have the guest satisfaction rating, where 1 is dissatisfied, 5 is satisfied. That will allow us later, after we do the text mining, will allow us to relate the words extracted from ExtractText with the overall satisfaction with the hotel. I should warn you that the data that we are going to see is not a random sample of hotel reviews. I drew a stratified sample so that I have 200 reviews with a 1 satisfaction rating, 200 reviews with a satisfaction rating of 2, etc., etc. So stratified sample, stratified by satisfaction rating. And this particular example is included in the Kamakura analytic examples contained in the Kate suite of tools. And if you navigate through the tabs, you're going to see here on the third tab the example for ExtractText. So here we have first document, the guest was not satisfied, satisfaction rating of 1, and here is the text of that customer's review of the hotel, and so on and so forth. And you can see that I have 200 reviews with a satisfaction rating of 1, 200 with satisfaction review rating of 2, etc., etc. And to do the text mining, I go to Add-ins, Kamakura Analytic Tools, Extract Text. It tells you exactly what this tool does for you. It asks you to highlight the range with the data, which is essentially the first 2 columns. First column must contain document IDs. Second column must contain the text for each document, up to 5,000 characters. And it already highlighted the relevant range from A1 to B1001. We're going to read 1,000 documents. Then it's asking, is this data, are these texts in English? In this case, it's yes. If it's not in English, you answer no, and then it's going to ask you, is the text in Spanish? If it is in Spanish, you answer yes. If not, it's going to assume that the text is in Portuguese. If it's not in English, if it's not in Spanish, it has to be in Portuguese. In this case, the answer is yes. It already did all the extraction, and then it's asking you, how many of the most frequently used words do you want to retain? The default is 100. I'm going to retain 100. It already gives you the frequency in decreasing order for each one of the words. The most frequent word is room. The second one is hotel. The third one is NBSP, which I don't know what it is. So I'm going to say, filter out this additional word. And I'm going to keep everything else. So NBSP, I don't know what it is, so ignore it. And it gives you a warning, say that depending on how many documents you have, this extraction, mining, and coding might take a few minutes. In this case, in our particular example, we don't have that many, so it's not going to take that long. Okay, so here we have the adjacencies. You can see that hotel and room are fairly likely to appear in the same document. While, let's see, one that is rare, relatively rare. Here it is. Front and great. So usually when somebody is mentioning front, they are unlikely to associate that with great. So this is essentially a distance, or actually a proximity matrix. Large number means they're close together. Small numbers means they should be apart. And that's the kind of matrix that you can use as input in multidimensional scaling. The other output produced by ExtractText is frequencies. So what we have here is the document ID, which in our case is the overall satisfaction rating, which we used to replace ID. And here we have the counts. So how many times each document mentioned room. First document mentioned room once, second document does not mention room. The third document mentioned room in different forms 5 times, and so on and so forth. So what we have here is a table of how many times each one of those words or roots have been used in each one of the 1,000 reviews. All right. So that's pretty much the output from ExtractText. Adjacencies is a word-by-word affinity table, and frequencies is a document-by-word frequency table. And since we have overall satisfaction on the first column, we can run all sorts of supervised learning models. For example, linear regression, stepwise linear regression, partial least squares. But we have to remember one thing. Most of the tools in Kate require that the first column contains a ID for each rule. So I'm going to create, and we want to use this column B here as a dependent variable. So I'm going to create a sequential ID number here. That way, if I ask for any kind of supervised learning analysis, it already will assume that first column contains an ID for each row. And I'm going to show you one example. Add-ins, Kamakura Analytic Tools, and I'm going to use PLS regression, partial least squares regression. This regression will simultaneously reduce the space among predictors. So it's going to reduce the 100 predictors into 1, 2, 3, 4 components, but in a way that maximizes their ability to explain the dependent variable. So my dependent variable is overall satisfaction. I have 99 predictors. Remember, I filtered out one of them. So I have 99 word counts. I'm going to run this PLS regression that will reduce the space in the predictor set, but in a way that maximizes the ability of this reduced space to explain the dependent variable. So it says here a maximum of 50,000 rows, 150 predictors, and up to 20 principal component or a PLS factors. The first row must contain labels. First column must contain row labels. Let me try a solution with 2 latent dimensions. There we have. We created 2 latent dimensions, latent factors, and here are the loadings for the first and second factor. Then simultaneously, PLS runs this regression with the ratings as dependent variable and the factor scores as predictors. Keep in mind that it's different from principal component analysis because these loadings here were calculated at the same time the regression is being run in a way that maximizes the ability of the 2 dimensions, 2 latent dimensions in the predictor set to predict the dependent variable. And our R square is 58%. And in column D, we have the standardized regression coefficient. So let's color code the standardized coefficient. Let's take the top 10 largest values and color them in green. So those are the predictors with the strongest positive impact on guest satisfaction. And let's color code the bottom 10 items in red. So let's see what tends to explain guest satisfaction. Guests are more satisfied when they mention stay, clean, great, helpful, comfortable, block, lovely, and definitely. And they're perfect and quiet. And they are least satisfied when their review contains star, hallways, condition, disappointed, money, tiny, rate, dirty, wall, window, and so on. So this gives a clue of what you want to avoid to improve customer satisfaction. People tend to complain about not like the hotel because of the window, because of the wall. Maybe the walls are too thin, dirty, rate, tiny. So okay, those are the things that tend to lead to a negative, a low guest satisfaction. Now, let's look at the two dimensions that explain guest satisfaction. I'm going to copy the loadings. I wanted to copy these loadings here to another sheet. Let me call this loadings. So those are the two loadings that show the direction of each one of these characteristics in the two-dimensional space. So I can map these loadings by using my scatter plot with labels. So I wanted to map loadings 1 and against loadings 2 and mark each point with the word. There we have. So this is the space, the two-dimensional space that helps us understand guest satisfaction. I asked Kate to jitter the labels a little bit because they tend to overlap a lot. But I need to do some improvement in the jittering because it's not jittering a little bit, it's jittering a lot. But we can move some of those labels by hand. It's not that hard. Oops, I got the idea. Now, if you stare long enough at this map, at this chart, you find some meaningful patterns. For example, you can see in this region here, we have words that are related to location. Subway, station, close, distance, park, location, square, walk, block. They seem to be all related to the same component, location. While if you look at this location here, you see words that seem to relate to the staff, front desk, check-in, things that are happening in the first floor at the lobby. Again, there are many other aspects there that if you stare long enough, you see patterns. The other pattern you find is that pointing in this direction here, southwest, you see things that are related to dissatisfaction. Dirty, disappointed, money, tiny, condition, hallways. And then in the opposite direction, pointing to the northeast, you see lovely, definitely, comfortable, perfect. So PLS provides this kind of insight. Not only allows you to identify words that have a positive or negative impact on the dependent variable, but also gives you a sense of how the predictors relate to each other while at the same time relating to the dependent variable. That's the beauty of PLS. So if you want your hotel to do well, you want your hotel to be in this direction. Towards the northeast. Because all the good stuff points in that direction, while all the bad stuff seems to point in the opposite direction. Dirty, weight, walls, tiny. So this direction, the northeast direction, seems to indicate more satisfaction, better satisfied guests. And we can see this or confirm this by looking at the factor scores. So here we have the factor scores for each one of the 1,000 reviews. And I'm going to copy these factor scores in another sheet. Let me call this scores. So here, each row is one review. So I'm going to use the original ratings again as my ID for each review. Now that I have the satisfaction rating associated with each one of the scores, I can again use scatter plots with labels to map each one of those 1,000 reviews. And this time I don't want to jitter. I wanted to have them exactly where they're supposed to be. And I'm going to clean up this a little bit. I want to put the data labels in the center. And I want to format. And as we expected, the lowest ratings tend to be in the southwest of the space, while the highest ratings seem to point in the direction of the northeast. So the highest scores tend to be in this direction, northeast. The lowest scores, ones and twos, tend to point in the southwest. You're doing well if your hotel has a score in this direction, in this area here, farthest to the northeast. And you're doing terribly if your hotel is positioned on the southwest. So again, we have here a combination of text mining through ExtracText and supervised learning through PLS regression.